Alright, thanks for watching, and today we'll calculate a very neat limit, namely the limit as n goes to infinity of n factorial to the 1 over n. And for this, we'll use a result that I've proven in a previous video on the pre-ratio test, which simply says that the limit as n goes to infinity of the ratio of the successive terms, of the ratio test if you like, it's less than or equal to the limit as n goes to infinity of the root term. So Sn to the 1 over n. And by the way, this is perfect for this problem because this is of the form something to the 1 over n. So let Sn to be n factorial, and let's calculate the ratio term. So then Sn plus 1 over Sn becomes, well, absolute value of n plus 1 factorial over n factorial, and that just becomes n plus 1. And therefore the lim inf as n goes to infinity of the ratio term, again, the smallest possible limit of the ratio term is just the smallest possible limit of the function n plus 1, but that's just infinity. Because this thing blows up to infinity. And therefore, what do we get? We get that the lim inf as n goes to infinity of n factorial to the 1 over n is infinity. And because the lim inf is the worst possible limit of your sequence, we can actually conclude that the limit as n goes to infinity of n factorial to the 1 over n is infinity. In case you're not convinced, just stick around and I'll prove this, because what is the lim inf as n goes to infinity of this? Well, by definition, well, how do you calculate the lim inf? It's just the inf, but after a long time, after a long capital N. So you take the infimum of everything after that threshold, but for a long threshold. So it is the limit as capital N goes to infinity of the infimum of Sn, in this case n factorial over 1 over n, where n is bigger than capital N. So now, what do we know? We know that the lim inf is infinity. So this means that for any capital M, this infimum is eventually bigger than capital M. So for any capital M positive, there is n1 such that if capital N is bigger than n1, then the infimum here of n factorial to the 1 over n, where n is bigger than capital N, is bigger than n. But then what does that imply? If the minimum is bigger than a number, it really means all the values are bigger than that number. So if we're saying the minimum is greater or equal to n, it means all the values are bigger than or equal to n. So in other words, n factorial to the 1 over n is greater than n for all n bigger than n factorial, capital N. And then we're actually done, because what would it mean for this to go to infinity? It means for all capital M, there is a capital N such that if n is bigger than capital N, this is bigger than m. So in other words, this really shows that the limit as n goes to infinity of n factorial to the 1 over n is infinity. And therefore we're done.